Okay, till yesterday, I think we stopped at abstraction. Okay, so I've like there are a couple of couple of things which we did not complete it. Like one is encapsulation. Okay, so let me start from there, and then we can continue with other topics. Okay. 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 What is encapsulation, right? Uh, I'll just tell one example. Okay, so if you have a water bottle, okay, and it is filled with entire bottle was filled with water, you know, and you have two marbles, okay, inside that water bottle. One second. Okay, yeah. So so if you want to pull those marbles out, okay, without spilling the water, so is it possible, right? It's not correct. So, and if you have some, okay, tongs, to pull those marbles, okay. So, like, you have a pair of tongs, okay, to pull those marbles, then, it is possible, like, those, without touching the water, and, water will not actually spill out, right? So, what exactly the concept here, right? The marbles that you cannot touch directly, okay, with your hands, and to pull out, and but there is a way that you can pull out, okay, so using those tongs, right? So the concept here, consider these two tongs as a methods, okay, and those two two marbles as a variables, okay. So these variables is considered created as a private, okay, and these two tongs helping us to get those private variables to access them uh, as a setter or a getter method together, right? So encapsulation is that, okay, it is one of the object oriented programming concept, okay, which describes the idea of bundling variable and methods together, okay. So so what kind of variables? So when it is declared as a private, so if you're not able to access them directly, they you can access them using using a setter method and a getter method, right? So yeah, this is what, okay, the you know the variables are declared as private, and the methods to access them as public, so so that they can be accessed from outside of the class, okay. So then only these methods are cap used to set or get the values of the variables. So you got the thing, right? Encapsulation provides a protected space, okay. Encapsulation provides a protected space for data members and restrict access outside of the classes. So you cannot access those private variables directly, but there is a way that they provide, using these methods. Okay, you can you can add some value to that. You can, you can get that value, whatever it is, there is a set and get methods, okay, that you can utilize on those private variables which are there inside a class. Okay. Okay, so how, we can achieve this encapsulation in Java, right? I just took an example of student class. Okay, there is a private, in that actually I have given, name as a private. Okay. Okay, so and then and the roll number. Okay, so roll number is, I have took it as int data type, and it is also a private member. So for roll number and name, we have a method called public void set name, which is taking a parameter string new name. Okay, and that new name is getting assigned to the variable whatever we have in the student class name, right? So similarly, actually, we have set roll number int roll, and this role is getting assigned to a roll number variable, which is inside the student class. Okay, so in the above example, okay, what you see, we can see the same, the name and roll number are declared as private, as we learned above. Actually, variables are will be declared in the private, and the methods will be declared with the public, right? So that you can access those methods outside of the class. Okay, and the private variables will not be accessed, outside of the class. Okay. Yeah, so what exactly it tells, right? These two methods, okay, we can access public, we can call them directly within, in a different class. Okay, different class, and we can use it, either, we can set the value. Okay, so I did not added any public get name and get roll number methods here. Yeah, but we can add those things, get name and get roll number, to get the values of these private. Okay, I just added only the set name, okay, to just make sure, that we can add, or we can update the private values, whatever private variable values, okay, using this set name. Okay, so the only way that we can change the value of private variables is only through the setter and getter, sorry, setter methods. Okay. Okay, so now what I've done, actually, what there is another class. I took it, for class main. Okay, and I just added object one dot set name rocket. Okay, so what I've done, actually, I just I'm utilizing that student class. Okay, student class, and I'm passing a data I'm using that public method set name, and passing a value to that set name, okay, as a rocket. Okay, so now I'm sorry, yeah, so when I call that method, actually, the set name rocket. Okay, so the name is equals to new name, right? So new name is passed as rocket, and the name will be new name value will be moved to name. Okay, that means, the private variable, the private data member value has been changed to rocket. Okay. Okay, I think, the concept you have understood, right? Like, even though they are the private members, private data members, using these public methods, we were able to access them. Okay, only the concept here is actually these two set methods can assign the values for the private data members, right? So that is the encapsulation, actually, creating a bond between a variable and method. Okay, private variable and method, it's called as encapsulation. And whatever the private member, okay, private data member, you cannot access directly, from the, by declaring the student class object, but you can still access them, okay, using these public members. Okay, yeah, I just given that, it's how it calls and all. So what I've done actually here, I have added one more disk name, okay, set name, and which is printing those name value, whatever we have it on the student class. So I just added dot object one dot disk name, and it printed the output as rocket. Okay. Okay. So let us find out to know what we have learned. Okay. We can access data members directly even if they are declared as private. Is that true? Okay. Yeah, that's correct. Okay, so let's go to the next one. In order to achieve encapsulation, methods are declared as private and variables are declared as public. No. Okay, false. That's correct. And okay, so if you see here, what will be the output of this? Just to make sure you understand the concept. So yeah. Okay, that's correct. Yeah. Okay, so to summarize, right, what exactly encapsulation is. So encapsulation is a concept in object-oriented programming which describes the idea of bundling variables and methods together. Okay, so the variables are declared as private and the methods access them as a public. Okay, so that they can be accessed outside from the class. And encapsulation provides a protected space, okay, for data members and restrict the access outside of the class. Okay, so this is what is an interface, right? This one of the thing is left actually. Okay, we did not covered it. Okay, so I'm just covering that one very quickly, and we can go for the next concept. Okay, yeah. So what is an interface, right? Okay, so you guys already know about the class. Okay, but what we exactly achieve with inheritance we'll try to understand now. Okay, so let us consider if you want to write a class. Okay, uh, we have to write a classes for cars which displays their individual features. Okay, we will require different classes for different cars. Okay, so but there are a lot of features which are same across these cars, right? Okay, so we have to keep all these features in a single class so that we can either extend that class, and you can use it everywhere instead of duplicating that. Okay, so what we can do, we have two options. Okay, either you have to go with a class, either you have to go with an interface. Okay, so what exactly interface does? Actually, interface can interface also works in a similar manner. Okay, so you can just create, once again. Okay, so interface acts as a reference for the other classes. Okay, so what exactly it does, right? In the class you can write, a method implementation. Okay, and you can write, some logic into that method, right? But in the interfaces you don't require that. Okay, actually you can just declare that method. Okay, and once you extend or once you implement that interface into a class, then you write the implementation of those methods. Okay, so it is like, only the declaration of the methods and some constants in the interface. Okay, and these methods and constants can be used by classes implementing that interfaces. Okay, so what exactly we achieve, right? We achieve abstraction. Okay, so interfaces are used to achieve complete abstraction. Okay, and if you remember, we discussed a very small concept at that time when we are learning inheritance, that is multiple inheritance. We mentioned, like, multiple inheritance cannot be possible without an interface, because interface provides these kind of concept. Okay, okay. So an interface acts as a reference, class for the other classes. Is that true? Mhm. Okay. Okay. So how do you write, basically, the interface? Actually, how to write a class, but let's see, how to declare an interface. Okay. So it's a very similar to the class, but we use a keyword called interface, while creating an interface. Okay. So public interface and interface name. Okay. An interface is abstract. There is no need to use abstract keyword to declare the interface. Okay. Okay. So when you say the interface itself is abstract, then we might have a doubt, like, what exactly happens with that methods inside the interface, right? So everything is abstract. Okay, so the methods declared inside the interface don't need the keyword, because the interface itself acts as an abstract. So they're also abstract by default. Okay, and the methods in an interface are public by default. Okay, so this is how we write an interface, a public interface student, and we use that void display name, void display rule number as a interface methods, because yeah, we can implement them. Okay, which contains two abstract methods, display name and display rule. Okay, so these are the following statements, which are correct with the respect to an interface. Okay, so we achieve complete abstractions. Okay, with the interfaces, and we have an interface, is a collection of abstract methods and constants, and to declare an interface, the keyword interface is used. Okay, so these are the three. And right now, how to implement it, right? We have to we already know that we use extends keyword, okay, to implement the existing classes. Okay, but what we use here, okay, what kind of keyword, right? Interface uses, if you want to implement the interface, you have to use implements. Okay, implement as a keyword. Okay, so if you see the right side, actually, we are implementing an interface using a class name, interface name. Public class and class name implements the interface. Okay, interface name. So the name of this class, okay, is followed by the keyword implements, okay, which is followed by the interface name. So once you write implements that interface, so you have to implement all the member definitions which are available on that interface. Okay, I mean to say, let's say we have two abstract methods which are present in that interface. So you like whenever you are implementing that, you have to definitely implement those two methods. Otherwise, you will get an compile time error that you did not implemented one of the method of it. Okay, so let's see one example. Okay, so what I've done, actually I just implemented that student, okay, interface which we declared earlier. So I was using that display name and display rule number. Okay, so I have just added a couple of system print statements. So can you guess what exactly the output would be? Okay, yeah. So a class can implement an interface, okay, but just like a class can extend other classes, on interfaces can extend other interfaces. Okay, so you might understood, right? If you want to extend, okay, an interface to an other interface, yeah, you can still do that. Okay, so that's what, something like this. Okay, so public interface name extends some other interface. Okay, so if you see here, so I just created a new student interface. Okay, extends student. Okay, so I have one more extra abstract method which is called as admission number. Okay, now if I extend, now if I implement the new student, okay, to one of my class, okay, so I need to implement three abstract methods. Okay, three abstract methods to into my class. Hope you got it. Okay, so an interface can inherit other interfaces using the keyword, using the extend keyword. Is that true? No, listen carefully. Okay, so an interface can inherit other interfaces using the extend keyword. Okay, let me show you back. Okay, just a minute. So what I'm trying to say here, right? If you see here, we use our own keyword extends, right? So to extend other interface, yeah, we use extend keyword only, right? It's okay. And to interface, to summarize, whatever we learned now. So an interface is a collection of abstract methods and constants. Okay, and interfaces are used to achieve the complete abstraction and multiple inheritance. Okay, and an interface is abstract. There is no need to use that keyword. Okay, and by default, all the abstract, interface methods are also abstract. Okay, and we can use implement as a keyword, okay, to implement the interface, and you can extend another interface to the current interface using extend keyword. Okay, and a class can implement more than one interfaces, okay, at same time. Okay, so let me come to the new topic, that exceptions. Okay, what is an exception? Okay, so is it is similar, like the hurdles, like what we get it when we are driving a car. Okay, so let's consider. Okay, so when you're driving a car, actually, if you got a speed breaker. Okay, so what you do, you apply some brakes, right? you know uh, Depending on your speed. So it it actually brings down your you know uh, your speed to certain level. Okay, so that means you're on very speed, so you just came down to a normal speed. Okay, so this is exactly the exception does to our program. Okay, so it brings down, okay, the complete process, okay, of our program to stop somewhere else. Okay, so and it what it does, right, actually it going to stop your entire flow of the program. And okay, so if we handle these properly, okay, if we handle these exceptions properly, you know so we can continue our still continue our normal flow of the program. Okay, so how we handle them, how we handle these exceptions, what kind of methods that we have it to handle, and how do we identify in the applications, or in the projects that we are doing, okay, at offices. Okay, right, how do you identify an exception, on which condition that exception cost. Let us learn that, a few tips for it. Okay, so but before learning them, actually we have to just find out, just understand the concept of exception, right? So let us continue here. Exception is an event that disrupts the normal flow of the program, right? Exception handling enables us to handle runtime errors. Okay, thus it maintains the normal flow of the program. Okay, so exceptions can occur due to user's error and programming error, or due to the failure of any physical resources. Okay, so let us go to the next slide. Okay, so what helps us to handle runtime errors and maintain the normal flow of programming? Any guess? Okay, yeah, that's very simple. Fair question. See, exception handling. So what kind of exceptions we have? We have two exceptions. One is checked, and the other one is unchecked. Okay, and what is checked, right? A checked exception is an exception which occurs at the compile time. These are also known as compile time exceptions. Okay, so the programmer needs to handle these exceptions before running the program. So because you cannot run the program with those compile time errors. Okay, so nowadays actually compile time errors are very easily fixed, because earlier we used to write in a notepad, and then you do a compile on that Java classes, and then you will be able to identify what is a checked exception, what is what is the issue with that code. But nowadays actually we were using this IDEs and everything. Okay, so it always gives you that exception whatever you're writing the code immediately. Okay, and you can correct them. So we are good with checked exceptions. Okay, so you can still correct them. Okay, if you have proper syntax, or mostly syntactical errors that happens in the checked exceptions. Okay, and yeah, so let me go to the next one, right? An unchecked exception. So what is unchecked exception? So unchecked exceptions are kind of logical errors and programming bugs come under checked exceptions. Okay, so so errors are not exception. Okay, I'll come to there. Okay, so what is an error, right? In programming, errors are something which is out of the user's control or programmer's control and cannot be handled like exceptions. But exceptions, right? Exceptions is something, right? Logical errors and programming bugs. Okay, so these things, some way we can handle them properly inside our, the particular program itself. Okay, how we can handle, okay, what kind of features that Java provided, to handle these kind of exceptions. Let us understand that. Okay. Okay, so what is this? An unchecked exception is an exception which occurs at compile time, and a checked exception is an exception which occurs at the at the time of execution. Is this true? False. That's correct. Okay. 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 Let us understand the try, catch, and finally. Okay. So what is this try, catch, and finally? Okay. So Java provided three different kind of functions. Okay, different kind of blocks: try block and catch block and finally blocks. Okay, so what it does, this try block is used to enclose the block of the code which might throw an exception. So when you're writing a program, so you think there is some exception that it's going to throw. So let us take some scenario. Okay, you're trying to write a connection class. Okay, so where exactly the connection to a database. Okay, you are connecting to a database. Okay, let's say you connected that, and you are calling an SP. Okay, store procedure, or you're trying to execute a query. So you already got the connection. Now you are writing, you are passing that connection to a method, and you're trying to execute some query. Okay, let's say that query might have some issue. Okay, so what kind of issue it says? Like, let's say you have written select star from employee table, where certain employee ID is equal something, right? So in while you are writing the program, okay, so you just added the name as emp, but in the database, if you have the table name as a different name like employee, something like that. Okay, so what Java does, actually, it is going to call that it is already connected to the database, but when it is trying to execute that query, the table or view is not exist in the database. Okay, because there is a mistake in the program, right? Instead of employee, you have written emp. Okay, so in that case, actually, there is an exception. It throws back from the database saying that, okay, the past query is having unwanted table, like the table itself is not exist in database. So some kind of exception will be thrown back. That exception is comes under a class called SQL exception. Okay, so basically all the SQL exceptions can be handled using that SQL exception class. Okay, so what we do, so the exception occur at one place, right? While connecting to a database and you're trying to execute that query. So the execution of the query, okay, will go to a try block. Okay, because that is where actually the block of the code which is trying to give you some exception. Okay, so the exception, where exactly the exception throws, okay, it is in the try block. Okay, so the try is followed by a catch and final block. What exactly this catch block does? Okay, so let's say you have just now you have a db exception which got thrown, okay, from the try block, and you have to catch those exception using the catch block. So catch is having a pretty much a kind of a parameter which can catch different type of exception classes. Okay, so what is exception class, right? Exception class was provided by default from Java. Okay, so exception is I'll show you one example. Okay, you will be able to understand. So exception is the main class which is having subclasses like runtime exception. Under the runtime exception, you have some arithmetic, null pointer, you have a different array index, out of bounds exception. So there are multiple exception classes which were provided default in default by Java. Okay, so these are all the frequent program exceptions which occurred by when we do a programming, like when a developer does something. Okay, so let us consider, like let us see how the code looks like. Okay, so something like this. So if you see the try block, which is having a code and which generates some kind of exception, and I'm sorry, one second. Yeah, so that catch block can catches that exception. Okay, so how try and catch block looks like. Okay, so this is how. So exception name and E I have written, right? So that is kind of a class name which we are trying to generate that exception. And if you're not aware like what kind of exception it does, you can still simply use exception class which can handle all the exceptions. Okay, and it can it can give that whatever the statements that you wanted to write in the catch block, you can still write them. Okay, now what is finally, right? So finally is a block always follow a try or a catch block. Okay, so this is a block of the code which is executed irrespective of whether the execution is handled or not. So that means, so let's say in the try block actually you have handled the exception with the catch. Okay, and whenever that exception occurs, okay, or whenever if it is not occurred, okay, if you want to execute some of the code which is mandatory to that method or that class, okay, you have to write that particular block into this finally. So finally is the block, okay, which always which will be always executed irrespective of the execution of your program. Okay, so it will definitely execute at the end of the program, the finally will be called, and whatever the block of the code that you have written inside the finally block, this will be executed. Okay, okay, so if you see something, okay, the program which is very simple, and most of the people know about this, arithmetic exceptions. Okay, so when you do divided by zero, okay, for any of the number, so what would be the output? So the output would be like with 0, 10 by 0 is kind of the value is infinite, right? So you cannot write that. Okay, so Java throws arithmetic exception when we try to divide by 0. Okay, so this is what I was trying to say. Java.lang.arithmetic exception, which is one of the exception class which was provided by Java. Okay, and this handles all the arithmetic related exceptions when we are doing the program. So, but if you see this code, right, you did not you did not mention anything about arithmetic exception, but you still used only the exception class over here instead of that. Even though it has arithmetic exception, our program got executed and it catch that exception, and it gave you this output saying that okay, it is arithmetic exception divided by 0, right? So because exception is the class, is a super class for all these runtime exceptions. That's why you did not get any other exceptions. It still handled those exception properly and gave you the output divided by 0. Okay, this is the system.out.println slash e. Okay, sorry, e, that gave you arithmetic exception divided by 0. Okay, so let us add finally block, okay, to this. Okay, so the finally block is executed, division by 0 is displayed below the okay. So as I mentioned, right, even though if it is issue with that catch block, if even though if it is like any exception occurred in the try block, okay, so the finally block will be executed properly, okay, and you can write something in the finally block. Okay, so how the throw will be work? Okay, so um, let's say you have some kind of user defined exceptions that you wanted to write, okay, in the Java. Okay, you don't want to use, sometimes you don't want to use the predefined exceptions whatever the Java provided. So if you want to use exceptions within your project with the user defined exceptions, okay, or you can still use the you know the existing exceptions, like exception classes which was provided by Java, but instead of catching them you wanted to throw back to the caller. Okay, let's say you call a method and you are handling that exception and you are giving back to them, okay, some output. Okay, but you don't want to do that. Okay, you have to throw that exception, that let client handle that exception. Okay, depending on that exception, he will try to display something or he will try to add something else. Okay, so how to throw those exceptions, right? We have a throw keyword in Java, so you can just use throw new exception. Okay, okay, so what we have done here, uh, you know like a simple program, I just updated something. Okay, so that is main class. Okay, and I have given a static void div. Okay, int number, as I'm passing it if number equals to 0, and I'm just throwing arithmetic exception divided by 0. Else I'm just trying to print that 20 divided by that number. Okay, so what is this case, right? The division, in the division, actually, I'm calling that division directly with a 0 value. That static method is going to throw back to me saying that, okay, there is arithmetic exception. Okay, if you pass 0. Okay, so I need to handle that exception, right? Okay, so either I will try to add a try block in the void main, or else that exception will be directly displayed into the console. Okay, so if you see the output, it says that exception in thread main java.lang.arithmetic exception division by 0. Okay, thus using the throw, we have thrown a custom exception which is says division by 0. Okay, so if you see here, throw new arithmetic exception, right? So arithmetic exception, we have a class, but still, you are writing your own text, right? What exactly it says. It's a division by 0. Okay, so let's see. So what we learned, right? The correct syntax to throw an exception. Which option it is? That's correct. C. Are you sure, Anurag? Yeah, it looks similar, but you are missing a semicolon. It is throw new exception The B is the answer. Okay, no problem. Yeah. So try this, which of the following statements are correct with respect to the exception. So first option is exception is an event that disrupts the normal flow of the program. So exceptions are same as errors, and try, catch, and finally are used to handle these exceptions in Java. And exceptions handling maintains the normal flow of the program. Correct. 1, 3, 4. That's correct. I think 3, 1, 3, 4 should be the right answer. Yeah. Okay. So the finally block is always executed irrespective of the of whether an exception is thrown or not. Yeah, that's true. Thanks. Okay. Which of the following keywords use it to throw a custom exception? Finally, catch, throw, try. That's correct. Throw. Okay, so you all got like what exactly an exception is and where we use try block and catch block and finally block. Okay, and how we throw you know how we throw user defined exceptions. Okay, using a throw keyword, right? So all these things we learned for in the exception classes. Okay, but there are few tips that I wanted to give you, okay, in the real time projects, actually, how you guys need to identify those issues, right? So there are two things that we use it, okay, when we are writing, when we are designing or when we are, developing an application, okay. So the locks are very critical, okay. What kind of locks, okay? The simple way, you don't know anything about that project, but some task has been assigned to you to find out what exactly this issue is causing. Okay, so they will provide some lock to you, okay, saying that okay, this kind of exception occurred, okay, in the project flow. Okay, so when you see that you don't know anything about the project, but you still need to identify that exception. Okay, there are two ways. Okay, one is the simplest way. You don't require to search anything. Sorry, you don't require to know about the project, how it work and all. Okay, just find out the exception whatever they have given, right? So their Java provides a very brief, sorry, a very detailed exception information, in the logs, right? So in those logs, actually, what it does, okay, so where exactly it has broken, like where exactly it stopped that logic flow. So it generally provides a number for that, okay, which line number was broken and which line number caused that exception. Okay, so let's say one of the exception that you got as null pointer exception. Okay, and they gave you that exception detail to you, and you were able to identify, okay, so in so and so class at this line number you are getting a null pointer exception. So when you see a null pointer exception, try to remember something. So in the above logic, okay, somewhere we are trying to connect some database, or somewhere we are trying to connect some other place, or we are trying to retrieve something from session, or we are trying to retrieve something from somewhere else. Okay, so what we do, like let's say some you are trying to use that a name variable, okay, in this flow, and this name was retrieved from a database connection. Okay, let us consider that. Okay, so when you call that database connection, let's say the connection itself is not created because of some issue, and you are handling that exception properly, okay, saying that okay, there is a no connection available, so I'm not going to return you the name, so name will be always null. Okay, so but when you handle that exception properly in the class, Okay, so let me go back here. Okay, yeah, here. So instead of throw, what you're doing, actually you are connecting to the database over here, and you are catching that exception. Okay, and you are resolving it here, saying that okay, there is an exception happened, and you are printing some of the log over there saying that okay, there is no connection available. Okay, I'm not sending back the name value to the caller. Okay, so the name is not written properly to the caller class. Okay, so now name is having a null value, and without checking that null, okay, thinking you handle the exception properly in the classes, and we still use that name method, sorry, name variable, okay, to continue our flow of the program. So that kind of scenario, actually we get a null pointer exception. Okay, because we did not have a null check when we retrieve some data from the methods. So hold those null checks. Okay, whenever you are writing some program, and if you are trying to retrieve something else, okay, from different calling a method, or calling another class methods, and connecting somewhere else to get something. Okay, try to do a check, null check, before writing your flow program. Okay, you are continuing the flow of the program. So you when you add these kind of null checks, you will definitely avoid those null pointer exceptions. Okay, and make sure there is one more tip. Okay, so whenever you are writing some kind of collections related, or arrays related programming, right? So when you're trying to retrieve, so maximum to maximum, try to find out the dynamic size of that. Okay, like you cannot do a static, sorry, you cannot declare that size of array on your own. Okay, without verifying the data which is coming and storing into that array. Okay, so in those cases, what it happens, like you might see some array index out of bounds exceptions. Okay, so these are very basic examples which I have given right now, but there is one more thing that you can still find out an exception which is not at all like kind of related to these things. Okay, so you called a service, let us consider you called a service. Okay, that service got a failure. Okay, so you did not get any response. Okay, so generally what we does, okay, we nowadays actually it is everything related to microservices, rest calls and everything, right? So you are expecting an output from the rest service within some time frame. So we call it as like the response time, right? Response time should be uh, between that, right? So like let's say 2 seconds is the your maximum response time for calling a service. Okay, so if it is past that 2 seconds, actually we will mark it as timeout, and we continue our flow of the program, right? So there are few things. Okay, like whatever you learn now is prospective about the Java, what kind of exception it occurs. So when you go for the service calls, there are some kind of HTTP codes, and there are also an exceptions which we handle, right? So there are exception codes, sorry, not exception codes, response codes which we receive whenever we have some issues with the service, right? So you have to handle them also properly with those. So for these kind of services also, we have certain exception classes which are handled, which are provided by either the framework that you are using. If you are still using the Java framework, and you still have certain classes to handle them. Okay, and how to identify them, right? With the response codes. Okay, so you generally get a response code from HTTP, okay, while calling those services, like 500, 200, and 202. Okay, some 400 errors. Okay, so all these exception codes, okay, you have to remember them. Okay, when you get a log, if you see certain HTTP code written by a service, okay, you can still imagine, like, you can still find out depending on that response codes. Okay, so something has happened, like, we were expecting 200, which is a success response, but we got 500. Why we got 500? Because that server itself is down. There is something wrong with the server. It did not responded back. So if you got a 400, what is a 400 error? So 400 error is something like, some issue with the programming, right? So some issue with something else. Okay, so there are some response codes that you need to find out. Sorry, you need to learn them first, before before checking that exceptions, right? So whenever you get some time, just go through these exception response codes, and what are all the available exceptions, what we have it in Java. So most likely you will see null pointer exceptions in the projects. Okay. uh, s- Other than that, actually, system failures, okay, some might be something because of the network failures. So these things we cannot handle. Okay, so if it is network failure and all, then it is out of our programmer hand, and you have to work with your network team or middleware team, that they can help us find bringing up those servers, right? So except the programming, yeah, you can do two things. Okay, you can just go through the log and find out which place it was failed, and if you're not able to find that, Java still does, okay, where exactly that null pointer exception happened, or some certain exception happened. It is still going to give you a very detailed exception. Just follow that exception to the end of that stack trace, and you will be able to definitely see where exactly that exception got caused. Okay, there are some other exceptions also, which typecast errors and all. Okay, so when you go through this exception concept, you will be able to understand them. Okay, if you have any questions on it, please let me know. I can cover them. Okay, and other than this, there is one more thing. So in like in companies, actually we use different type of logging. Okay, so that logging, like most probably most of the companies use a Splunk. Okay, so Splunk is like you whenever you wanted to verify some logs for the application, you just need to log into the Splunk, and you can pull the logs, current logs, depending on certain queries. Okay, there are some queries, and they will be giving you some organization ID for you to search for that the application related logs. Okay, so that logs will also help you to understand the flow. Okay, and if it is causing some exceptions, yes, it is going to give you those details as well. Okay, so let me just cover quickly. Okay, uh 1 second. Yeah, I know I'm out of time, but I just wanted to just cover a brief introduction about collections, and then tomorrow we can see the examples of it. Okay, so yeah, generally till now, actually we were able to identify only the single variables. Okay, the single variables and how it stores the data and all, right? So if you ever thought of egg tray, right? Egg is a storage tray that shown is a in the same picture above. The only purpose of the egg tray, right, to store eggs, right? So systematically without breaking them, correct? So it it has multiple, one tray for multiple eggs instead of having one for each. So which sounds right, which sounds weird, right? If you want to store a similar kind of data, but you are storing into a different variables, so which is like creating a lot of variables and a lot of code into your program. So instead that if you are able to create all these all these data into one, okay, which looks like very good, right? You can still handle the same thing, right? So similarly, an example, so what we have a class of full students, almost 40 of them. Okay, and we need to store their names in the computer using Java. So you definitely know how to do that, right? Now you are going to create 40 string variables with the name 1, name 2, name 40, and storing that values in them. It looks weird, but that is the option that till now. So let's see, what we can do, with that. Okay. So the above technique, right? What we, creating those 40 strings, it is like, a solution, but it is like, looks very weird. Okay. Creating all those strings, right? Now we thought like, we should have something which holds all these string variables into one, at one place. Okay. Like storage place, right? So yeah, we can still achieve this, using Java. So first concept is array. So array, how it works actually, array is going to have multiple things. Okay. And it has a very special storage, which can store multiple values into that. Okay. Just see the above picture. Okay. So I have some 0 to 9. Okay. So which are called those, index. So array maintains an index. Okay. So using that index, actually, we used to store values. We used to retrieve the values. Okay. Using those index. And so similarly, we have lot of collection classes which are available in the, in Java. But I just took, at least, 5 classes. Okay. Uh, but I'm not going to cover them. I'm just, just giving you the brief introduction of it, and I'll just provide you some sample examples. Okay, let us cover them in tomorrow's class, and we can start with threads and parallel programming, parallel processing tomorrow, and after that we'll go with Git related classes. Okay, so yeah, today, if you have any questions, please drop me message in the WhatsApp group, or else, you can still ask me. Okay, that's all for today. Yeah, thank you everyone.
Thank you.